Hi, Year 10. We continue with probability today, and the first one we're going to work on is the fact that the sum of all of the probabilities of our outcomes will add to 1. So let's just get a definition of that down. That the sum, so it just means the sum means adding together. The sum of the probabilities of all outcomes adds to 1. Remember, 1 was saying that something was certain. Another way to say that is 100%. So that means that if I list all of my possible outcomes, then the chance of one of those things happening is certain, is basically what this sentence is saying, that if all outcomes added together, if I list all outcomes, then one of those things must definitely happen. So an example of that would be if you have the probability of getting a heads plus the probability of flipping a tails, then we know that those probabilities are half, and they are all my possible outcomes, and we can see that they add to 1 because they are all my outcomes. Another example might be, say I had a team and they had a probability of winning, probability of drawing, and a probability of losing, then all those must add to 1 as well, because these are all my possible outcomes. One of those things is certain to happen: a win, a draw, or a loss. An example of how I can work out a missing probability, then let's say I have a spinner, and let's keep it purple. Let's say I have a spinner and one bit of it is purple and the rest is white, and I spin it and it lands on one of these things. Let's say I'm told that the probability of landing on purple is 2/5. Then I can work out the probability of it not being purple, or in other words, the probability of it being white. So the probability, I'll show you some new notation here, not purple, you just put a little dash there, must be 1 minus 2/5, because I know that all of it together must add to 1. So I can get what the probability of not purple, or equally that's the probability of it being landing on white, would be 3/5. I could also do this as a decimal, because 2/5 is the same as 0.4, so I could work that out by doing 1 take away 0.4, which is 0.6, which is the same as 3/5. So there's a few examples. Make sure you get all of that down in your book, so everything that's on this page, get it down in your book. Right, we're just going to have a go at a couple of questions based on that then. So here's 2 questions for you to have a go at. I'll just make it bigger, pause it, have a go at it, and then pause the video, have a go at it, and then I'll go through it now. So get your red pen out. Should have had a go at this by now. The important thing to do is show your working here. Look, it's 2 marks. Those 2 marks means that 1 mark's going to be for your working, 1's going to be for your final answer. So there are red, blue, yellow counters and green counters in a bag. That's what this table's showing. Counter is picked at random from the bag. The table shows the probabilities that the counter will be red, will be blue, and will be yellow. Complete the table to show the probability that the counter will be green. Well, I know that all of these here are all my possible outcomes, so I know in total they must sum to 1. So that means that if I do 1, take away 0.2, take away 0.4, take away 0.3, I'll get what the probability of being green is. So 1 take away 0.2 is 0.8, take away 0.4 is 0.4, take away 0.3 is 0.1. So that's my final answer. You can do that in your calculator, or hopefully you just challenge yourself and do it in your head as well. Another way you could have done it is added up all of these, 0.2 plus 0.4 plus 0.3 which is 0.9, and then done 1, take away 0.9. If you find that easier to add them all up, then take away from 1 rather than doing it like I did it first off. Right, so mark that in red pen, correct it if you got it wrong. Now onto this question. Julie randomly selected chocolates from a box containing dark milk, white and mint chocolates. There is an equal chance of selecting white or mint chocolate. So that's a key bit of information there, so I'm just going to underline it. Copy and complete the table below to show the probabilities of selecting each type of chocolate. Well, I know in total, oops, I've done that the wrong way around. These must add some to 1. So I know that in these gaps here, they must add 2. Well, if I do, let's do it the other way here. 0.15 plus 0.35. That's 0.5. Therefore, if I do 1 take away 0.5, then that gets me 0.5. So I know that across these two boxes, let's change colour so it's a bit clearer. Across these two boxes, they must add to 0.5 because these two here add to 0.5. That means that I know all of them add to 1. We saw that if it's certain that I must pick a dark milk, white or mint altogether. So 1 take away 0.5, these two boxes add to 0.5. Now the key bit of information I underlined before, and I'll highlight again, equal chance of selecting white or mint, means that they have the same probability of happening. So that means to work that out, I can do 0.5 divided by 2, which is 0. I've run out of space here, but it's 0.25. So therefore this is 0.25 and this is 0.25. I could double check my answer in my calculator. Let's add up all those numbers. 0.15, add 0.35, add 0.25, add 0.25, adds up to 1, so I know I'm doing something right. So the key bit of information there was equal chance, means they have the same probability of happening. What's the probability of Julie selecting a chocolate that isn't mint? Well, there's two ways I can do this. I think the easiest way to do it is the probability of something not happening, so not mint, is going to be equal to 1 minus the probability of mint. So that is 1 minus 0.25, which is 0.75. Another way I could have done it was added up dark milk and white. Which again obviously gets me the same answer of 0.75. So not mint, 0.75. We can do 1 take away the probability of mint. Right, next thing I'd like to have a look at is sample space diagrams. Let's go back to this page here. And a sample space, so this is your next subheading. Sample space shows all possible outcomes, so it will list every probability of happening. One way to do this is list systematically. So systematically means you've got some system for listing them that helps you make sure you've got every single possibility there. So let's say I flip a coin twice. So I could list all the probabilities. I could do, well, I could get a head then a head, could get a head then a tails, could get that in the reverse order, so I could go tails then heads, and I could go tails tails. So see how I've sort of done that systematically. I started with both heads and I ended with both tails. Another way to do that, and a common way to do it, is draw a sample space diagram. So I'll show you how I could use a diagram to help me list all these as well. Is draw a table and list your probabilities. So let's say that this is my first flip and this is my second flip. Then I can do head, 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 tail, tail then head, and tail, tail. And notice I've got all the same 4 outcomes as I've got here. So the table just helps with that. Let's use that example of a win, draw, and a loss before. So let's say a team plays 2 games. and let's say it lists all possible outcomes. Bit messy there. So we could have a win, draw, or loss. Win, draw, or loss. Doesn't really matter, but let's say this is my first game and this is my second game. Then I could have a win, then a win, win, then a draw, win, then a loss, draw, then a win, draw, 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 loss, loss, whoops, loss, win, loss, draw, and then something that Crystal Palace would do, loss, loss. Right. Couple of questions. So just like before, there's 2 questions I like to have a go at. Have a go at this one. Pause the video. Make sure you're not just copying what I do when I come back to it. Have a go at this one. Read the question carefully. Maybe just write down any keywords that you're picking out. And then I'll go through them now. So 2 spinners are numbered 1 to 4. They're both spun, and the product. So product means that we're multiplying the 2 numbers together. Is found. The sample space is shown to the right. What is the probability of the result being 4? So that's 4 exactly. So if you haven't had a go at it, make sure you do now. Maybe you didn't know what product was. Now you do. Try and have a go at it. What is the probability of the result being 4? Well, I can see that if I spin a 1 and a 4, I'd get 4. If I spin a 2 and a 2, I'd get 4. If I spin a 1 and a 4, I'd get 4 as well. So I can see that out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. So notice that 16 isn't to do with this answer being 16, but it's because there's 16 possible outcomes. And there's 3 4s, so my answer is D, 3 over 16. Make sure you mark that or correct it in your book in red pen. Right, each one of the numbers 1, 2, 3, 4 is written on a card. 2 out of the 4 cards are randomly chosen without replacement. So that means that... let's change this actually to with replacement, because that makes it a question which we haven't done yet. So with that now, have a go at this question again. Or just sort of see it as you're picking 2 cards. Let's just completely cross out that sentence. You're just picking 2 cards at the same time. Picking 2 cards at the same time. Find probability that these sum. So that means that these answers will be wrong. Oh, I should have read this question more carefully. Anyway, have a go at it again now. So ignore that without replacement. Ignore these answers. They might not be any of those answers there. And then I'll show you how you should have approached this question now. So we need to draw a sample space diagram. And the sample space is going to show the sum of the numbers. Sum, remember, means adding them together. So my possibilities are 1, 2, 3, and 4. 1, 2, 3, and 4. So if I'm summing them together, then that would be 2, 3, 4, 5. 3, 4, 5, 6. 4, 5, 6, 7. 5, 6, 7, 8. So find the probability that the sum of numbers on the 2 cards is less than 6. So let's just highlight all the bits that are less than 6. All these numbers are less than 6. All of these numbers, but not that last one, are less than 6. That's less than 6. And that's less than 6. So let's count all those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 out of the possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 10 out of 16, which I can simplify to 5 8. But it doesn't say simplifying the question, so you could have either answer. Right, tomorrow I'm going to set you a must watch task based on the stuff we've done today. That's adding to 1, all probabilities, adding to 1, and sample space diagrams. Any questions, please email. Have a great day.